Hello and good morning. Let's take a look here. I want you to memorize these rotation rules, and actually they're pretty easy, so watch this carefully. If you look here and you go 90 degrees, let's say this point is here. Okay? All right, draw that diagram, and then put a point here and then connect this. 90 degrees this way, according to the rule, well, it's going to end up somewhere over here. Okay? So 90 degrees clockwise, you change the x and switch. So if the point is -5 and -7, let's say, or -7, -5, you would change this one and then switch it. So the new point would be -5 and +7. Okay, so just remember, if you go clockwise, you change the x and switch. If you go counterclockwise, that's the other way, that's this way. So counterclockwise, you would change the y and switch. Real simple. And then if you go 180 degrees either way, 180 degrees that way or that way is the same point. So if you go 180 degrees either way, you just change both, but don't switch. Change both only. That's it, real simple. In 270, if you look here, let's say the point's here, and you want to go 270 degrees clockwise. Well, let's make this into 90s, like that. 1, 2, 3, 4. So 270 clockwise would be over here, which essentially is 90 degrees counterclockwise. So that one you would change the y and switch. Okay, so this just gives you some idea of how to figure this stuff out. Okay, but the rules are real easy. I would just memorize the first 3. Okay, all right, let's move on now. Let's talk about some problems here. If you haven't already done so, go over there and grab 3 sheets of paper. So grab your worksheet B, and this is the exam review on the table. Okay, 3 pages. And I want you to work the first 5. Well, let's take a look at the first 5 here. You have this triangle ABC, which is this one, and it's grafted in this triangle here. All right, what sequence of transformations will map this triangle ABC onto that one? Well, let me think here. A reflection over the x-axis followed by the y-axis. Well, this is your x. So if you flip it from here to here, you would count. I'm just going to rough this up. So it looks something like that. And then if you reflect it over this axis, I could very well see this working. So that's a very good possibility right there. If you rotate it 90 degrees or 180 degrees about the origin, this one, let's see where it would be, 180. That looks like 180 right there. And then this point right here, point, let's see which one would match that. I guess it would be this one here. And so that looks like 180 as well. All right, so I'm kind of liking both of these at this point. But it also says a reflection over the line y equals x. So I'm going to scratch that one out. Maybe 180 might do it, but I don't think reflecting it. 90 degrees clockwise rotation about the origin. Well, think about that. Or translate it 8 units to the right. So you want to move it 8 units and then up 1 unit. Well, if you go over 8 and up 1, it's not going to be that one, so we could definitely scratch that one out. 90 degrees clockwise rotation would put it, let's see, 90 degrees would put this point over here, and followed by 90 degrees counterclockwise rotation about the origin. Well, let me see here. 90 degrees clockwise about the origin, followed by a reflection over y equals x. What I'm going to do here is just put a question mark, because really you're going to have to go through each one of those to figure it out, okay? Let me see here. Let me just see if I have the, okay. So this one right here is number 3 on the back side. Let me see what we have. So on this one right here, we actually have the answer as this one right here, okay? So, and that's the one that I liked originally, but really you have to go through each one of these. So this one requires a little bit of time. Let's take a look at this one here. It says number cubes. What you need to know is that opposite faces add up to 7. So like if this is a 3, the face way over here that you can't see has to be a 4, okay? So if you look, this is a 5, so the face on the other side right here has to be a 2. So if you take this and you turn it one click 90 degrees or one click 90 degrees counterclockwise is what I'm looking at there. So let me see here, 90 degrees counterclockwise. So on that one right there, rotate the top cube 90 degrees clockwise. Let's see how that works. Okay, so yeah, 3 and the 5 has to be over here. So this one is actually going to go clockwise one turn. Okay, so let me take a look at that and make sure we're with that. So we have a 5 here. If we go one click on the top, that's this one here. Okay, so if we go one click, the 3 moves into this region here, and that's where the 3 is. And then over here is where the 5 is, and the 5 shows up. So we want to go 90 degrees clockwise on that. And then the bottom one, if you look, you got to figure out where the 5 is. The 5 is back over here across from the 2. So you would have to actually turn that twice, okay? The 3, the 4 has to be on this side. So they rotated it 2 clicks to get that 4 to come over here. So I'm going to say counterclockwise 180 on that one, and that's what we have. And actually you could go 180 either way. So we're going to go with B on that one. Okay, so you got to visualize in your head how they're moving the cubes. Let's take a look at the next one, number 5. The triangle has these vertices. What are the coordinates of each vertex? And translate it 4 units to the right. So in other words, you're going to add 4 units to your x on all the x's. And then you're going to go 6 units down. That's a -6. So we're looking for, that gives me a -3 and 0. So I'm looking for -3 and 0. And it looks like it's this one right here. So I'm going to go with D. Sometimes you have to work a little further to get the answers. So I worked 1, 2, 3. Let's work the next 2. Which transformation will place the trapezoid onto itself? So on this one right here, what we're going to do is actually just flip this point over here and flip that point over there. So we're basically reflecting over the y-axis. So we're going to go with a reflection over the y-axis. All right, which figure has 90-degree rotational symmetry, 90 degrees? So if you take, let's say, an equilateral triangle. Let's just start with this one. So here's an equilateral triangle. Okay, so if you go 90 degrees rotation on this one right here, and we want to make it an equilateral triangle, if you want to rotate that 90 degrees, then it's going to be somewhere over here. Okay, and that rotational symmetry, the question is, if you go 90 degrees, and let me back up on this, 90 degrees is going to put this point like this. Okay, so in other words, it's going to look, when you rotate it only 90 degrees, something like that. That one's not going to work. The square, however, if you take a square and you rotate it one time, 90 degrees, one click, 90 degrees this way, this point's going to map onto that one, and this one on that one. We're going to go with the square on that. All right, work the next 5. Okay, select all polygons that have rotational symmetry. Rotational symmetry means you rotate it less than 1 complete turn. Now you can't rotate it 1 turn because they would all have it. So if you rotate this one 90 degrees, it definitely has rotational symmetry. This one right here, if you rotate it and rotate it and rotate it, well, if you go down just 90 and then 180, it would be on itself. So we want to go with that one. This one right here, if you rotate it here, it's going to be pointing that way. And then down, it's going to be pointing down. And then there. This one does not. This one right here, if you rotate it, let's see if we can get it onto itself. If we rotate it 90 and then 180, it looks like 180 is going to work on that one. And this one, you could just rotate it 90 degrees, and this point should match up. So we're going to say with those are rotational symmetry. Remember, it's less than one turn. Okay? All right, let's keep moving. So next, this one right here, consider, does it have the types of symmetry shown in the chart? Okay, so let's take a look at this one right here. So the question is, does it have the types of symmetry shown into the charts? And so into this, we need to take a look. All right, so let's start with number one, rotational symmetry with line H. Yeah, if you go 90 degrees, or two, actually this right here is, it's like 120 degrees here. Okay, because the whole circle is 360 and you got 1, 2, 3 of those. So 360 divided by 3 is 120 degrees. So that one is definite, yes. Line G is here, and this one says reflection symmetry onto that one. So if you take this and you flip it, let's see what it says. Line G is here, and so we want to reflect it over line G. So this one, if you look, reflection symmetry over line G, well, this point here would match up with that point there. Okay? And so this point is going to stay on line G, so that one's not going to move. This point, the distance from here to here is going to go from there to there. So it looks like the answer is going to be yes on that one. Okay. Reflectional symmetry over line M. Here's line M, and I think it's pretty much the same thing. So this is going to flip onto this one. So we're going to say yes onto that one. Okay, on the next one it says reflectional symmetry over line N. Well, here's line N, and if you reflect this point, it's going to end up somewhere over here. So that one's not going to work. Rotational symmetry, 90 degrees. So if you rotate this 90 degrees, if you look at 90 degrees, it's going to put that point somewhere over here. So I'm going to say no on that one. 120 degrees, that's a definite yes. Okay, from here to here is 120. And then 180 degrees would put this point down here. So I'm going to say no onto that one. Okay, be careful with those. Let's work the next one. We're going to do one more here and then we're going to stop. Which transformation will carry the rectangle shown below onto itself? All right, so let's see. If you reflect it over line M, well, this point would stay. If you reflect this point over line M, it's going to be somewhere over here. So I'm going to say that one is not going to work. If you reflect it over the line Y equals 1, well, let's see, here's 1 right here, and this is the y-axis. So make this darker. So from here to here, that distance would be the same as that. So I'm going to say yes onto that one. 90 degrees counterclockwise about the origin. No, because this side's longer. And if you go 90 degrees, it's going to be somewhere up here, something like that. And 270, 270 would be 3 turns. So that would be also looking up like that. 1, 2, 3 turns. I'm going to say no on those 2 right there and yes onto that one. All right, we're going to stop here. Let's turn our attention now to MCR. All right, MCR, grab 2 pages, and it's actually 1 page. So grab 1 page on table That's today's work, and that's by me. All right, let's take a look. On this right here, what you're going to do is distribute this negative sign. And when you distribute that negative sign, the front part stays the same, but the back part changes. Now you're going to add this up and get negative x. When you add that up, you get minus 2, and you're done. This one right here, to factor it, you can't take anything out. So you got to do 5 times 18. Okay, so let's figure out what that is. 5 times 18 equals. You get 90 on that one. Okay. Now, what we need to do is figure out what combination is going to give us a 1. So we have to factor out the 90. So a negative and a negative is going to be a plus and a minus. So you're going to be subtracting. Okay. So 9 times 10 is going to give me that 1 I want. So you're going to substitute this in place of here. So you're going to rewrite the front, rewrite the back one, and then you're going to substitute a 9x and a 10x in here. And the middle one's a minus, so you want the minus and the plus. Here you're going to separate or factor out an x. Okay, so this one right here, let me think here a minute. Okay, so we want to get rid of this here. Okay, so we want to factor out an x, and when you do, you're going to end up with 5, and actually it was a square. It's going to be 5x plus 9. Okay, that's correct. Now we're going to factor out a 2, I think, here, and a negative. So that's going to be a negative 2, and you're going to be left with 5x minus 9. Or actually it changes, remember, when you factor out a negative. Now this becomes the same as that, okay? So it's a little easy to get rusty on this factoring, but there it is, and that's how you do it, okay? All right, so today you have to finish this worksheet. This is a brand new worksheet, by the way, and it's factoring. So if you get stuck on any of these, this is a good review for factoring. Remember, MCR, you're going to have a test this weekend, and try to do well on it. You have from Friday to Monday. Don't put it off. Have a good day.